Hi, in this video we're going to be showing you how to do a chi-square test for goodness of fit. A chi-square test for goodness of fit is a way of evaluating the null hypothesis of a population that has more than one categorical variable. Okay, so before we go on with the procedure, we have to first see that all the expected values are greater than 1, and then you have to see that no more than 20% are less than 5, and this is just a rule of thumb. And those conditions do apply to what we're doing. Okay, this is just an example of how to use the chi-square test for goodness of fit. So this right here, this is the population percentage distribution. So basically, and it's of U.S. males aged 25 to 29 from a poll taken in the year 2000. So there were 28.1% of the males were never married, 56.3% were married, 6.4% were widowed, and 9.2% were divorced. And then the problem gives us the frequency for the sample of 500 that were taken. So we want to compare this to this in our HO and our HA hypothesis. So right here there was 260 out of the 500 that were never married, 220 out of the 500 that were married, 0 out of the 500 that were widowed, and 20 out of the 500 that were divorced. And this is just the sample frequency distribution of 500 U.S. males aged 25 to 29. Okay, so these are our hypotheses. This is our null hypothesis, and this is our alternative hypothesis. So our null hypothesis is going to be the distribution of the sample, which is this, is exactly the same as the distribution of the population, which is this. So, and we're trying to reject our null hypothesis. We're trying to say that the distribution of the sample is different than the distribution of the population. Which, if we were to compare these two, we would have to change this to frequency so they would both be comparable. And we would just take 28.1% of 500, which is the total right here. So, in other words, we're trying to find what the expected value for each of these would be if we took a sample of 500. So, because this is our population, our expected value for 500 for never married would be 28.1% of 500. So basically we're comparing this against the population to see how valid the population is.
Again, what we're trying to do is compare the two distributions between the population and the sample. So for marital status, for non-married of the population, the percentage was 28.1. So we take 0.281 times 500, which gives us 140.5. For married, the percentage was 56.3, so we take 0.563 times 500, which gives us 281.5. For widowed, it's 0.064 times 500, which gives us 32. And then for divorce, it's 0.092 times 500, which gives us 46. And these are our expected values of the population. We're gonna compare those to the observed values, which were given to us, and we're going to see if we can reject the null hypothesis.
So this isn't the actual sample that we got, that we supposedly collected of the sample of 500 that we got out of the book. This is the expected values, which just means we took the percentages that they gave us from the population. So in other words, 0.2 or 28.1% of the population, the entire population of U.S. males aged 25 to 29, there was 28.1% that were not married. So we're just applying that to the sample size of 500.
In order to see if the distribution in the sample varies from the population, we use the equation O minus E squared divided by E, where O is observed values right here, and E is expected values. And basically what we do, for example, for non-married, we would take 260 minus 140.5. We would square that and divided by 140.5, and that gives us 101.63. And we did that for non-married, married, widowed, and divorced. And when we add those all together, we get 161.75, which is x squared. And x squared is the chi-square statistic that we're going to use later to reject the null hypothesis. Alright, so our degrees of freedom is 3 because there's 4 variables: never married, married, widowed, and divorced, and degrees of freedom is always n minus 1. So we look at the 0.05 significance level in order to reject our null hypothesis. So when we look at that column, the value there is 7.81.
Okay, so the rule of thumb is that when your chi-square statistic is large, your p-value is going to be small. So the larger this number is, your chi-square statistic, the smaller your p-value is going to be. So since this number is much larger than 7.81, we can reject the null hypothesis at significance level 0.0.
Since the chi-square statistic value, 161.75, which we got, is much larger than the 7.81 critical value, we can reject the null hypothesis, which stated that the sample frequencies would be the same as the population frequencies, and that's not true. Yeah.
Okay, so this is the density curve for the chi-squared, and 7.81 is our chi-squared critical value, 161.75 is the chi-square statistic, and this is the rejection zone from 7.81 over to the right. And since 161.75 is much greater than 7.81, we're able to reject the null hypothesis.